second video segment that I'm making for this hybrid assembly. This is going to be an assembly, but two planes of symmetry being used. Remember, the first one, we did this problem, but no planes of symmetry were used. Okay, so let me see now. Where's the split? Here's the split. Here's the split. You can see that. You can see this. Now, there's two ways to do this problem. If you try this split here, it will tell you that it cannot split the surface. Okay? At least I don't think it can, but let's try it. It'll do some of the job, but the middle plane is like this. And if I say split, it tells you that, wait a minute, some of the stuff that you're trying to split are actually not solid. So are you sure? So my suggestion is a situation like this is actually say okay, but my suggestion is to cancel that, is to cancel this. Okay, go back to the block. Go back to the block. Okay, here's the block, the part design, and use the saw here and block and split it twice. And do the same thing when you go to the assembly, to the wireframe and surface design. The only thing is that where is the split there? You have to find it. I don't see it there, so the other option is to reset the toolbars. So tools, this can happen to you on the test, so you might as well remember how it's done. Customize. Just wait for a second. I mean, you can try to do this thing in the assembly, but you may run into some issues, so I decided to do it in the right spot. Okay, just wait. Okay, toolbars, restore all contents, restore all positions, close it. Hopefully you can find a split now. Right, I think it's right there if I'm not mistaken. Yep, right there. Okay, so split this way, and it doesn't matter which side you pick. And once again, split that way. Okay. Now, in order to split the surface, we have to go to the wireframe and surface design. So either generative shape design or wireframe and surface design. Let me take you to the wireframe and surface. Look for the split. Here's the split. So you split the surface. Element to cut is, of course, the surface. And the cutting element is going to be that vertical plane. Now, which side do we want to keep? Oh yeah, we want to keep this side, okay? Oh, it also kept me the other side, so let me see for a second. Is there a way? Well, obviously we don't have to mesh that side. That's okay, but I'm surprised because okay, I'm sorry. This cancel. Actually, undo this because that's really not what I wanted to do. I wanted to select the plane. Accidentally, I selected the sketch. So this split one, this split I want to delete. Okay. Oh. Why did I delete the first one? I didn't want to delete this. So Control Z, or let's say undo. Oh yeah, I don't know. I'm sorry. Okay, let's go back here. I really screwed this up. So let's go back to block, part design, split with this plane. Okay, and once again split with that plane. Alright, I accidentally deleted this. Now, oh, I see. Now we have to go to plate. That was the problem. I forgot to go to the plate. Okay, we go to the plate, and we go to the what are we there? Wireframe and surface design. That was my mistake. I tried to cut cut the plate while I was not in it. So wireframe and surface design. Now get the saw. Element to cut is this. Cutting element is that vertical plane. Yep, the other side, and do it again. Select the plate, and for cutting is going to be that plane, that vertical plane. Okay, good. Now I don't really have to do anything with these, because when it comes to meshing, I don't have to mesh these guys. I can leave it, and in fact, if you don't want it, you may even try to delete it. You can do that. Of course, you have to go to the legs and do this. So don't do it, please. Just leave it. Just don't mesh these things. All right. So we go to. I'll just hide them. How about these are hide? The only problem is that because they're all in the same, they're all in the same part. When you hide this, the other ones hide too. Okay, leave it like that. So now save everything. Actually, let's save everything after the cut. Good. So we're going to go to Generative Structure Analysis. CATIA immediately measures the block. We know that. Let me change the rendering here. All right. And now we're going to mesh the surface, the shell element, right there. And we're going to give it a thickness, whatever it was before. Give it a thickness, same thickness. And now we're going to mesh with beam element this beam, this leg. We don't have to mesh the other ones. And if you don't mesh the other one, they're not going to participate in the calculation. And the cross section is exactly what we had before, circular, same radius. So we select this and we say OK. All right. Now, if you look at the mesh, the solid, the shell, and the beam. Okay. So deactivate this and proceed with the rest of the problem. Deactivate that. Okay. So the bottom of this is clamped. Very good. This vertex is clamped. You can see that right there. Okay. And then we can create a connection between these faces and the shell. So connection. The first two that I'm going to do is going to be fasten. Okay. This, and for the second component, I'm going to hide that. For those of you who like to experiment with this thing a little bit, I could have done the side face and the face of the plate. Okay. And also the side face of this side and the face of the plate. I didn't do it like that. I'm doing it with edges. But as I said, for those people who want to experiment beyond what I tell you, instead of selecting this edge, you can select that face and the face of the block. Second component, this one, let's bring in the front. Okay. These are both going to be fastened. We might as well do that right now. So where's the fasten? Face to face. I can select from here, this icon from here, or you can go directly to the tree. So both of these are fastened. Okay. And then I create a rigid connection between this and the two vertices. So let me hide this. First component is this guy. Second component, now let's bring this in the front and hide this fellow and hide the connection that's blocking my view, that guy. And this one is going to be rigid. This is going to be rigid. Okay. Now the symmetry conditions. Okay. So let's see. When it comes to symmetry, let me bring this leg. When it comes to symmetry, surface slider on that face of the solid and this face of the solid, okay, and the edges of the shell, you must follow the rule for the shells. So let me uncheck all of these. So this edge lies in the XZ plane, does not move in Y, rotation is opposite. On the other hand, this edge of the plate, another one, let me uncheck these. This edge of the plate lies in the XZ plane, so no displacement. Actually, I'm sorry, this one was Y, yeah, this one is YZ, no displacement in X, rotations opposite. I don't know what I did with the first one, so let me check the first one, make sure that was not a mistake. So this one, it lied in the XZ plane, yeah, no rotation Y, rotations opposite. Everything is okay. So the load is applied on the top because we're taking 1/4 of that block. This should be reduced. This should be divided by 4. So 125, negative 125 pounds. Okay. Save the analysis, file, save management. The analysis, save as, go to the right folder, which is 2 planes of symmetry. And now we're going to run it, and I'm sure we're going to be okay. So there's the run. Ignore the warning. There we are. Okay. There. You can animate it. This is 1/4 of what we had before. You can look at the 1 mesostress, change the rendering, material shading. Of course, the beam elements don't have 1 mesostress. Well, I mean, as I mentioned in the earlier video, when you get paid to do these things and you're looking for accuracy or doing research, then you have to check these numbers, make sure that the thing does not yield, etc. So I'm just showing you the process behind that, and look at the deformation, which means deflection. These are not correctly generated on the screen. My graphics card, Lenovo graphics card. Okay, so this is it. We're going to stop here. Now the video segment is going to be repeating the problem, except that I will do everything within a single part. I'm not going to make an assembly, okay? Notice that here we had a product. We had an assembly made of block, plate, and legs, okay? And